just take a second and look around you. I mean, really look. The screen you're watching this on, the chair you're sitting in, literally everything is built from something. But what is all this stuff, really? Well, today we're going to crack the secret code and finally understand what makes up our world. At first glance, this is just a random pile of things, right? A key, a ball, a ruler, a plant pot. They couldn't seem more different. But I promise you, there is a fundamental connection that ties every single one of these items together. So what is it? What's the secret thread linking these completely different objects? That's the exact mystery we're about to solve. To find that answer, we've got to start at the very beginning, with the absolute foundational building blocks of our physical world. And you know what? It all comes down to one simple word: material. A material is just any substance that's used to create an object. It's the paper in your book, the wood in your table, or the metal in that key we just saw. It's the what behind every single thing. Take Gulan and Sheeta Hair. They're pretty excited about their new school supplies. Gulan's notebook? It's made of paper. And Sheeta's pen? Well, that's made of plastic and metal. So you've got two different objects built from three totally distinct materials. Okay, so everything is made of materials, got it. But there are so many of them. How do we even begin to make sense of this endless variety of stuff that's all around us? Think back to that first picture with all the objects. If you had to sort them into groups, how would you even start? It just looks like a jumble of stuff at first. Luckily for us, we've got systems for this. You could group things by their shape. Put all the round objects in one pile, or you could sort them by color, or we can get a bit more scientific and group them by the material they're made of, or by a property they all share, like, say, whether or not they're shiny. And this whole process, it actually has a name: classification. It's how we bring order to the chaos of the world by arranging things into neat groups based on what they have in common. This is basically the foundation of how we study materials. Okay, so this brings us to the really cool part of our investigation. The secret code of any material is really just its set of properties. So let's decode a few of the most important ones, shall we? First up, luster. This one is all about how a material plays with light. On one side, we have lustrous or shiny materials, think metals like iron and gold, and on the other, we have non-lustrous materials like paper and wood that have more of a dull surface. But here's a little catch. You've heard the saying, all that glitters is not gold, right? Well, it's scientifically spot on. Just because something shines doesn't automatically mean it's a metal. Sometimes a dull material can be polished or coated to give it an artificial shine, which reminds us that just one property never tells the whole story. All right, so let's move from sight to touch. Our next property helps us understand what makes something feel hard or soft. Hardness isn't just an on or off switch, it's more like a spectrum. A material is considered soft if you can easily squish it or scratch it, kind of like a sponge. Somewhere in the middle, you have something like rubber, which is definitely harder than a sponge, but way softer than, say, iron or stone. Every material fits somewhere on this scale. So we can sort materials by how shiny they are or how hard they are. But so what? Why does any of this actually matter in the real world? Well, this is where it all comes together. Let's do a quick thought experiment. A tumbler is a cup for holding water, right? We know it can be made of glass, or plastic, or metal, but why not cloth? Just think about it for a second. Yeah, you probably guessed it. The answer is pretty obvious, isn't it? Cloth isn't waterproof. The properties of that material are completely wrong for the job. You need a material that can actually hold liquid without it leaking all over the place. And that brings us to the most important point of all. We choose a material specifically because its properties are a perfect match for the purpose of the object we want to make. You wouldn't make a hammer out of rubber or a window out of solid wood, right? The properties dictate the function. It's as simple as that. Now, this whole idea of choosing the right material for the right job, this is not new. In fact, it's one of the oldest forms of science and engineering in all of human history. Just take a look at pottery in the Indian subcontinent. People were experimenting with clay as far back as 8,000 years ago. And over thousands of years, they perfected their craft, developing wheels and glazes and incredibly sophisticated baking methods all throughout these amazing foundational civilizations. I mean, look at these. These are not just simple pots. They're the result of some seriously deep knowledge. Ancient artisans knew they had to carefully select and clean the perfect kind of clay, then fire it at exactly the right temperature to make it hard and durable. They were, for all intents and purposes, ancient material scientists.
And this wisdom was even written down in ancient texts. This Sanskrit verse from the Rasaratna Samuchaya clearly states that the materials for making a crucible, that's a vessel that can withstand super high temperatures, are clay and iron. They understood that the unique properties of those two materials were essential for the task. That's the exact same logic we use today.
So, the secret code is out. Every single object you see was made from a material chosen specifically for its unique properties. The world isn't just a random collection of stuff. It's like a library of purpose-built materials. So now that you know how to read the code, what are you going to notice about the world around you?